All right. Good afternoon, good morning, good evening, wherever you are. Happy Stay Thursday? Thursday. Uh, Today, or right now, we are going to be talking about infrastructure from code. We're going to talk about what happened, what it was, what the promise was, and we're going to be talking about what's the next thing, and whether or not infrastructure from code should continue or not. So, first of all, thank you everybody for coming in and watching this session. I'm excited to talk about this topic. Before we get into it, my name is Alan Helton. I'm an ecosystem engineer at Momento. I am a career developer and lifelong learner, and I love being at the bleeding edge. So right now, as you can imagine, I do a lot of AI work, but a few years ago, I was really interested in the concept of infrastructure from code, which is something completely novel at the time. And I can see in the chat, yes, I am also a farmer. I am one of those people in tech that said, you know what, I want to do a farm, and I actually did it. I have turkeys and chickens and goats, and as of yesterday, actually, I have guineas, which are the weirdest looking birds you can imagine, and then just a massive garden as well. Do a lot of growing. So let's set the stage. Let's talk about infrastructure from code and what the promise was, if you're unfamiliar. So infrastructure from code was a mystery land where you could write application code and be done. And then it works in the cloud. Something that's really all of us say, that sounds really nice. That sounds like something that's really cool. But in practice, we'll see. We'll see what that actually translates into. But the gist was write your application code, nothing else. It runs in the cloud. Sounds great, and especially in like 2021, 2022, where the cloud was really taking off in popularity. So let's click in one level of detail on what infrastructure from code was promising. It was promising no YAML, which a lot of us are familiar with. Some of us like JSON. Some of us, we like more of an imperative style of infrastructure as code. I'm an AWS heavy person, so the references you'll hear me talking about is usually CloudFormation and CDK. Obviously, there's a whole lot more than that, but just off the tip of my tongue, it's usually going to be those two. So, YAML, that's a big CloudFormation thing. No context switching. And this is something that when I first got into the cloud was something I really, really struggled with. I was a long time, 10 plus years application developer, thick client desktop app developer written in WPF. And I would write my code, I'd hit F5 in Visual Studio and off to the races. But when I started learning cloud, I'd write my business code, look for that F5 button, it doesn't work or it doesn't really exist, then realize, oh yeah, I have to figure out what the infrastructure is that backs this code that I just wrote. So I'd always be context switching between my template file and my business logic. And that slowed me down, if you will, at least as far as infrastructure from code vendors considered it. And so because I wasn't doing any, or because you're not doing any context switching with IFC, that means you're super fast because really all you have to do is write your business logic and boom, cloud app. Very nice promise. Very, very cool. Now, a lot of people, a lot of vendors saw promise in this. And this is just a few. This is 7 of, in my opinion, the most popular ones, or the ones that had the strongest vision of what IFC could be. And they did a good job at the time abstracting out infrastructure from the actual code. And everybody here, everyone that you see on the screen right now, did it very differently. There are a lot of ways to skin this cat. And we'll take a look at a couple of examples here in a little bit. But what's interesting and what's unfortunate for lack of a better word, is that it didn't work. Spoiler alert, IaC did not work for whatever reason. In my opinion, what I did, or what I told all of the founders of all these companies back in the day, is that we're too early. People aren't ready to give up control. People aren't ready to have these types of abstractions. It's cool, but I'm just not sure we're ready. And so what happened as recently as 2025, these companies started dropping off. So Wing and Clotho, unfortunately, went under this year. They hung up the hat and no more, which is unfortunate because they were two of the really cool ones. But beyond that, we still have a lot of different IFC vendors out there. There are a few of them that are trying to figure out, how do we keep going? What's the pivot to make it so we don't go under and have the same fate as those other two? And I would consider that being more or less going out to pasture, to use a farm reference, which means they're in maintenance mode. So that's Ampton, Darklang, and Shuttle. They're looking for the right move next, because what they started off with as a premise, it didn't work. We'll talk about why. Which leaves Nitric and Encore kind of as more or less the winners. They're the ones that have been able to adapt the fastest and actually change the way that they approach infrastructure from code in a way that makes sense, that developers don't see it and say, ew, that's gross, get away from me. But it makes you wonder, there's only 2 names left up here from 7, and that is a very high failure rate. And when you think about companies, right, if 5 of the 7 go under or change their mind on what they're doing, you have to ask yourself, why? What happened with infrastructure from code? It was supposed to be this pie in the sky. I just write my application logic and then it runs in the cloud, right? I don't have to write YAML anymore. I don't have to do context switching anymore. I'm 10x developer now because I can move so fast and get things into the cloud. And so to figure out why, we are going to go over the list of benefits that IFC vendors were touting. And we're going to talk about what the subtext was a little bit between for what they actually meant. So one of the big benefits of IFC was you don't manage infrastructure, which sounds great. All I manage is the business logic, which is really the value add that me as a software company is providing. But what that actually meant is these vendors are the ones that are deciding what resources you deploy and how they're configured, which right off the bat, I know everybody watching this session right now can see, oh, I don't like that. I do not like that at all. Of course, there's some bells and whistles that you can turn, but you don't get the free-form configurability that you get doing things yourself. You also got to deploy faster than ever, but always the but. You had to stick to the patterns that the vendors were providing. The customization really wasn't there. I mean, it was there, but then you start getting into very, very specific cloud vendor configuration, which kind of makes sense, right? The higher abstraction you go, the fewer features that you get to take advantage of, because you have to match parity with everybody that you're trying to support. So if you want to move as fast as you can, you have to adhere to the guardrails, which again, people don't really like. Another thing, one of the biggest things that every single founder of these vendors told me was, you get best practices out of the box. But what people don't say, they're not your best practices. They're the vendor's best practices. And so that doesn't really work when you're talking about building enterprise level software or just software in general, because everybody has different compliance standards that they have to hit. If you're in the medical field, you have HIPAA compliance that is very strict. Personally, I was in government software, and I worked with criminal justice data on day in, day out, and they were very strict guidelines that I had to adhere to. And when I'm following the best practices of the sum of many, it doesn't work for me. And the last one here that the IFC vendors would tout that I don't actually see as a benefit in general, but I thought I'd share it because it's important, is they said you don't need to learn AWS or Azure or GCP or whatever cloud vendor that you're going to end up deploying into, which I have a problem with in general, because I feel like as a developer, you should have some of the responsibility of knowing where your stuff is going, where it's hosted, and how it works. But the subtext there was, trust us, we got you, especially when something goes wrong, which means when something does go wrong, you're really at the mercy of their SLAs, their support teams, and you have to deal with your customers. They proxy through you, you go over to the vendor. So kind of scary, really, when you're talking about this is the list of benefits from infrastructures from code. We can always look at, well, I don't love it. But all of these things can really be summed up in 3 words. What's a better way to say the value, or to say what infrastructure from code vendors were trying to get from you? It was, give us control, which I cannot think of a more stubborn group of people on this planet than software engineers. And I know that because I've been a software engineer for a long time, and I am extremely stubborn. And when somebody asks me to give them control, especially the type of control that IFC vendors were looking for, that was a no, thank you. I am not into that. But within developers, there's another group that really does not like to give up control. So if developers are already this A tier, I'm not giving up control, well, within developers, you have platform engineers and DevOps engineers that really don't like it. And why is that? I assume most of everybody watching today is one of those 2 roles, or tangential to those 2 roles. Well, we don't like it because control is your job. That literally is the job. You're going out and you're doing the research for everything that's new. You're vetting everything that works based on your company requirements. You are validating things adhere to the strict restrictions that you have. There's a lot of control that you can do yourself, do that work up front, and then disseminate to all of the engineering teams at your company. But these infrastructure from code vendors says, no, give that to us. We'll do that. And it just really doesn't work out. And it didn't work out. And we've seen that reflected in that list of vendors that just kept dwindling earlier on. So now we kind of understand why it didn't really work, what the benefits were, why it didn't really work, who were the players, who trashed out and who didn't. Let's take an example. Let's see what it looked like, because it was promising and it was actually genuinely really cool. Now, before I go through these, I have to put a disclaimer that I meant to say a few minutes ago. I have no skin in this game. I never worked for any of these vendors. I was a very interested, neutral third party when it was in its prime. I did consult with a lot of the founders from all of these, but I didn't actually work on any of these things. I just built with some of them and said what I thought worked and what didn't work. So let's take an example. Let's look at Wing. Now, when you're looking at it, the programming language kind of looks like JavaScript, but it's not. It's Winglang. Wing took the approach of building their own programming language that did everything. And why'd they do that? It's so the compiler could go and actually take all of the syntax that you've written and convert that into infrastructure, as opposed to like scanning the code and then figuring out what you want. Afterward, it was all built into the compiler and it did it for you. But what's really cool about just the promise of infrastructure from code in general and some of these abstractions that they did is, if we look here, it's like 20-ish lines of code. And what that code did was it created a timer that triggered every 2 minutes. When the timer elapsed, it would call a third-party API. and basically pull stock data. What's the current stock price of GME? And then it would fetch the last value out of an integrated cache. It would update said value, and then it would shove that value into a queue so you could actually see the trends of that stock price over time. And that's it. That's literally all of the code that it took to do all of it. All the infrastructure, all the app logic, yeah, that was it. So, it takes longer to explain it than it does to write it. It was really cool. On the other side of the screen, we have Clotho, and that does look like JavaScript because it is JavaScript. Now, what I liked about them was it could be integrated at any point of an application lifecycle and be deployed into the cloud. And how did they do that? They opted for annotations. So it was a little less magic hand wavy and a little more guided, I would say, developer guided. So you can look at the top, and I'm just to make sure I'm looking at the right hand side of the screen. I have in there that it's an execution unit. So really what that's telling Clotho when it's generating infrastructure is this is compute. And so it can go in and it would say maybe that's a Lambda function or maybe that's a container, and it would write the infrastructure as code to support that. I also have an annotation in there that says persist, which means that's a data layer. So for me, that likely meant DynamoDB inside of AWS, and it would do all those mappings and permission creation to do principle of least privilege. So that was really cool. That the business logic here, I wrote a chicken auction, of course, because I run a farm. I wrote the code and then came in after the fact and integrated Clotho into it, and it worked. And what I liked about this one is because this one actually generated the infrastructure as code for you, and then you deployed it yourself. So this one was like the least lift, the least integrated into the system. In my opinion, it was the one that developers were ready for. So it was a cool concept, and I really liked it. Okay, so there are obviously a lot of other examples. We're not going to go through all of them. We don't have that much time. So let's talk about the lessons that we learned, because there was a lot going on with infrastructure from code. There we go. Okay, and there's a lot of lessons. I'm not going to read all of these, but the highlights here from what we learned is as abstractions get higher and higher, it kind of makes us uneasy, because when you abstract and you take away configurability, we lose our comfort. We get out of our comfort zone because I can no longer maybe easily configure this bucket to be privately accessible. Maybe by default, it's publicly accessible. Terrible example, but you get the gist. It's something that as we get higher and higher abstractions, we get fewer and fewer configurable options. A big thing as well is that you had to trust the vendor, and all these vendors were new and they didn't have the years and years of experience that really gave us the comfort of saying, yeah, I believe that if something goes wrong, you will back me out, which is a problem a lot of startups have. But when you're talking about handing over the keys to your kingdom, it really doesn't work, and it doesn't make the speed worth it, the 10x speed worth it. The biggest one I would say, and I will read this one word for word, infrastructure is not a side effect. This is not something that really should be something that we don't consider at all, which is at its core what IFC was about. IFC was about writing your business logic and only focusing on that, and it runs into the cloud. But especially with the cloud, every decision is a business decision, and it's a business decision because it costs money. Depending on the scale, it costs a lot of money. So really, we need to intentionally design these systems and not let infrastructure kind of slide under the radar. So a big realization that I think these vendors had after the fact. So now that we know the lessons that we learned, how do you take those and progress from them? Do we abandon it entirely? Do we just say, well, that was a cool little side quest, let's just keep on keeping on? Or do we do something about it and continue and progress meaningfully? Well, I'm sure you guys have seen these two letters thrown around a lot. AI is actually the way that we are going to go forward. But I'm going to stop you right here, not in the way that you jump to conclusions to. AI is not here to take our jobs. It is not going to replace your platform teams or your DevOps team. It's not going to scan your code and generate infrastructure from it. It's not going to do that. These are, yes, the very easy things to assume that's what it's going to do. But if we let AI do that, are we really making leaps forward as a tech industry? No, we are not. So, while you can do all that, while you can vibe code your infrastructure, while you can create your RAG pipelines, that's not the way that we're going to really accelerate development and build better software. How we are going to do that is keeping humans in the loop, keeping developers in here and getting, basically being the decision makers from AI recommendations, if you will. And I'll go a little bit more in depth on that. But really the AI here is going to be going and looking at what you have. It's going to be fetching these data points. It's going to be doing a lot. And it's going to say, hey, I think this is the best. And it'll give you the reasons why. And you can say yes or no and ultimately pull the trigger on that. But the biggest point that I want to stick to here is this last bullet that I have on the screen, is that AI is going to monitor and it's going to observe your live infrastructure. What we need to stop doing is thinking infrastructure as code is a one-time thing. It's not something that we're going to set up and forget when we're building an application for the first time. It's something that actively needs to change as your business requirements change, as your application grows, and as you actually see how people are using your application. So in other words, what we actually need to do is ditch the phrase infrastructure from code. We're not going to use that anymore. V2 of infrastructure from code is adaptable infrastructure. And I also realize the irony here that the acronym for that is AI, but we're not going to camp on that. Really what we need to do here is we need to focus on making sure that infrastructure is staying relevant with the actual real usage of your app and how the consumers are taking it. And so what does that look like? What does that actually mean? So the AI, yes, it'll do its thing, but adaptable infrastructure is going to look at itself basically. It's going to say, hey, I'm seeing some patterns here. And given that you choose to optimize for cost versus latency or fault tolerance, because you can't really optimize for all three, given your optimization for cost, and that's what's most important to you, I think, because customers are only using your application from 8 a.m. to 5 p.m., we should either turn off your containers after 5 or temporarily switch them over to serverless functions where it's only a pay for what you use on demand thing because you're only getting 10 requests in off hours. Instead of letting your containers sit idle, we can optimize the spend that way because you care about cost and switch the infrastructure over. But really that only can work if you have something that's actively monitoring the real active usage. Now, if we didn't use AI for this, if we had a team of data scientists behind our application that said, I am going to take all these data points myself, analyze them, and make recommendations, well, that takes a long time. And they're often feeding through millions and millions and millions of data points. So often by the time they're done and they've written their report and they've handed it over to their boss, well, that data is probably stale and you need to start over. So what we're doing with AI and adaptable infrastructure is going from this weeks to months feedback loop down to minutes and seconds, because the machines can do it much faster than we can, and they're a little bit better at detecting anomalies than we are. So I want to leave some time for questions here at the end. I know I'm only about 5 minutes left, so I'm just going to recap real quick. So infrastructure from code didn't work because A, we were too early, and B, we were trying to take control away from people, and people don't like that. There's a lot of nuance to control. There's a lot of nuance to configuration. It wasn't the right thing. But how we're going to proceed, we're not going to call it infrastructure from code anymore. We are going to adapt, collaborate, and improve on infrastructure that's live and make it best for what our business actually needs. So thank you, everybody. I hope you found this interesting. Infrastructure from code is a genuinely fascinating topic, and I'm sad to see that it didn't work. It was really cool in demos, but I think in practicality, it was not the right fit for us. So if you have any questions, or if there's been questions during the talk, I would love to hear them and answer them.
Yeah, we have a few questions to kick off with. So one of them is, how about using something like .NET Aspire, which is an infrastructure-friendly framework for container-based workloads?
I haven't actually used that. It's hard for me to say to give advice on that one. I'm not familiar with what that is.
Okay. There is a question. Are there any companies or tools that you see that are doing adaptable infrastructure?
The closest I've seen is actually serverless framework. And it's not all the way there yet, but the foundation has been laid. And they are very, very close to actually getting that up and running. They have modified or appended, enhanced the way that they define infrastructure to be able to say in one word change, are things running in a container? Are they running in a serverless function? And they're already tracking usage metrics. So really it just needs to flip that bit to turn the AI on and say, yep, let's go ahead and recommend you switch that over.
Okay, thank you. Another question here. What do you think about using Gen AI generated code to provide self-service infrastructure?
Gen AI generated code providing self-service infra. Is that like a meta question? Is that using Gen AI to create an app that does that? I will tell my best answer to that is an anecdote from recent experience. And I was full on vibe coding in Cursor, where all I was doing was just giving text prompts and saying, now do this, or this header doesn't look right. Can you make it match this? Now this functionality needs to go and call this API. And I got pretty far. I got like 150 prompts in before my Cursor membership ran out of premium messages. And then I had to go back and actually do some coding myself. And I saw that code was not maintainable at all. It was dirty. It didn't clean up when I asked for big changes, and it was extremely hard to follow. And I don't see LLMs being in a spot right now that's a good idea.
Okay. So one other question here, and you sort of talked about this a little bit when you talked about adaptable infrastructure, but I often hear about people throwing infrastructure or more CPU, memory, et cetera, poorly optimized code. Would an infrastructure from code or an adaptable infrastructure platform essentially do that for you via auto scaling, or is there a better way of handling that?
You're like poorly optimized code is going to have multiple symptoms besides latency. You'll likely see race conditions. You'll likely see and race conditions that manifest themselves in almost impossible to reproduce defects. And you'll see you'll see random things that pop up that aren't great. It's really not just a latency thing. So you can basically changing the hardware is not going to solve software problems, and is my answer to that. So an IFC platform setting up auto scaling is not going to really affect the long-term maintainability of a piece of software. You still have to write code well.
All right, and unfortunately, that's kind of all we have time for. We have a bunch of other questions, but we'll try to get back to them after the fact. Thank you for the talk, and thank you so much for telling us what happened.
Yeah, thank you, everybody. Appreciate the time.